morning, one and all. This is Vijayawda-1 Devi, Department of Mathematics. Today we can discuss about this topic, numerical integration. Okay, guys, first we can start with general quadrature formula for equidistant ordinates. Okay, first we can discuss what is meant by general quadrature formula. First we can define that y is equal to f of x be a function which takes the values y0, y values goes to y0, y1, y2 and so on yn corresponding to the values of x are x1 is equal to a, x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h and so on, xn is equal to a plus nh. Starting value we are treated as a and the last value we can treat it as b. So that h is equal to b minus a is equal to nh. Then general quadrature formula is integral of a to b f of x dx is equal to h into n y0 plus n square by 2 delta y0 plus n cube by 3 minus n square by 2 by 2 factorial delta square y0 plus and so on, where n values goes to 0, 1, 2, 3 and so on. This formula is known as general quadrature formula for equidistant ordinates because x values are all are equidistant values. First value is a and another value is second value is a plus h. That means we can add some h, then we are getting the second ordinate. Again a plus h, then you are getting the third ordinate. x2 is equal to a plus 2h. So that is general quadrature for equidistant ordinates. These x values are all are equidistant ordinates. Okay, this is general quadrature formula. In this general quadrature formula, we can put n values goes to, we can write n is equal to 0, n is equal to 1, 2, 3 and so on. Okay, then we are getting different quadrature formulas. In this chapter, we have 5 methods to solve the definite integrals in this chapter. So, one is trapezoidal rule and the second one is Simpson's 1/3 rule. The third one is Simpson's 3/8 rule. Fourth one is Boole's rule. And the last but not least, that one is Weddell's rule. In these 5 models we are getting in the general quadrature formula, we can substitute n is equal to 0, n is equal to 1, 2, 3, all values. Then we are getting general quadrature formulas. In that general quadrature formula, we can simplifying, we can apply these 5 methods. One is trapezoidal, second one is Simpson's 1/3 rule, third one is Simpson's 3/8 rule, and fourth one is Boole's, and last one is Weddell's rule. Okay, today we can discuss about starting model trapezoidal rule. Okay, model 1. We can write trapezoidal rule. Let y is equal to f of x be a function. Then formula goes to integral of a to b y dx is equal to h by 2 into y0 plus yn plus 2 into y1 plus y2 plus and so on yn minus 1, where h values becomes to b minus a by n. Okay, so y values goes to y0, y1, y2 and so on y. First we have to consider first value and last value. So h by 2 into y0 plus yn plus 2 into rest of the values y1 plus y2 and so on yn minus 1. We can find the h value, formula is goes to b minus a by n. That means integral of a to b, a is called lower limit, b is called upper limit. So h value goes to upper limit minus lower limit by n. Okay, that means given some he is given in ordinates, that's why we can apply this form, h is equal to b minus a by n. Okay guys, next we can do some small problem in this model. Right, next we can go with small one. Evaluate integral of minus 3 to 3 x power 4 dx by using trapezoidal rule and taking he is also given h value is 1. Okay, he is given by using trapezoidal rule. Already we know the formula, integral of a to b y dx is equal to h by 2 into y0 plus yn plus 2 into y1 plus y2 and so on yn minus 1. Okay, now we can write, first of all we can write given condition. Given is integral of a to b y dx is equal to, given integral is integral of minus 3 to 3 x power 4 dx, and also he is given h value goes to 1. Okay, now you can compare. In the lower limit is goes to minus 3, upper limit is goes to 3. That's why we can write a is equal to 3, a is equal to minus 3, b is equal to 3 and h is equal to 1, and y value goes to x power 4. Okay, now we can substitute given values. X values goes to h is equal to 1. H is equal to 1 means x value. So ordinates a to enta stand minus 3. Minus 3 plus 1, that is minus 2, because x naught is equal to a. X1 is equal to, I can say that a plus h. That means here h is 1. So minus 3 plus 1. Then the second ordinate is goes to minus 2. Minus 2 plus 1, that is minus 1. Third ordinate. Next minus 1 plus 1, that is 0. Now we can add h value. 0 plus 1, that is 1. 1 plus 1, that is 2. 2 plus 1 is 3. That means first we can make x ordinates. In the previous general quadrature formula, we can say that a naught x naught is equal to a plus h, a plus 2h, a plus 3h, and so on. That's why in the starting initial value we can add h value. Minus 3 plus 1, minus 2, minus 2 plus 1, minus 1, minus 1 plus 1, that is 0. 0 plus 1, 1. 1 plus 1, 2. 2 plus 1, 3. Okay, now we can evaluate y values. Suppose you can substitute x is equal to minus 3. Then y is equal to minus 3 whole power 4. Minus 3 whole power 4. That value becomes to 81. Because minus power even numerator, it will becomes to plus. So again y is equal to minus 2. Minus 2 whole power 4. 2 2s are 4, 4 2s are 8, 8 2s are 16. Okay, next. Again you can substitute y is equal to, x is equal to minus 1. Minus 1 whole power 4. That is minus 1 power 4 is even number, it will becomes to plus 1. Next 0. X is equal to 0, that means y value is also 0. Next again you can substitute x is equal to 1. That is then y value goes to 1 whole power 4 is 1. Next again x is equal to 2. 2 power 4, that is 16. Again last value, x value you can put on x is equal to 3. That is 3 power 4, that is 81. So we can make the table. X values minus 3, minus 2, minus 1, 0, 1, 2. Corresponding y values. We are getting 81, 16, minus 1. 1 second. 81, 16, minus 1. 16, 1, 0, 1, 16, 81. So he is using in which method? Trapezoidal rule. By using trapezoidal rule, we have integral of a to b y dx. Formula goes to h by 2 into y naught plus yn plus 2 into y1 plus y2 plus and so on yn minus 1. So starting value y naught, y1, y2, y3, y4, y5, this is y5, y6. Okay, now we can write the formula h by 2 y naught plus y6 plus 2 into rest of the values y1 plus y2 plus y3 plus y4 plus y5. Okay, now you can write y naught, that is starting value. Y naught is 81 and the last value is 81. You can write y naught plus y6, 81 plus 81 plus 2 into rest of the values 16 plus 1 plus 0 plus 1 plus 16. Okay, now you are getting 81 plus 81. 81 plus 81, that is 162 plus 2 into 16 plus 1, 17, 17 plus 1, 18, 18 plus 16, that value becomes to 34. So 162 plus 2 into 34, 68. So you are getting the answer 115. So by using trapezoidal we can find out the value integral of minus 3 to 3 x power 4 value becomes to 115. We can use numerical integration by the method of trapezoidal rule. Okay, next we can go by how we can form trapezoidal rule theorem. First now we can discuss about. First we can discuss about statement. Let y is equal to f of x be a function which takes the values, corresponding values y0, y1, y2 and so on yn corresponding to the values of x are x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h and so on xn is equal to a plus nh, and the last value we can treat it as b, so that b minus a is equal to nh and h is equal to b minus a. Then formula is goes to integral of a to b y dx is equal to h by 2 into y naught plus yn plus 2 into y1 plus y2 plus and so on yn minus 1. This is the formula. In this formula we can use, already we can done one problem. Okay, right. Here y values goes to y0, y1, y2 and so on yn, corresponding to the values of x are x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h and so on xn is equal to a plus nh is equal to b. We can prove the theorem is h by 2 into y0 plus yn plus 2 into y1 plus y2 plus and so on yn minus 1. Okay, now we can see the proof. Right. First we can write, given y is equal to f of x function which takes the values. In the statement already we can write it as y0, y1, y2 and so on yn, corresponding to the values of x are x0 is equal to a, x1 is equal to a plus h, x2 is equal to a plus 2h and so on xn is equal to a plus nh is equal to b. Okay, right. We can write, put n is equal to 1 in general quadrature formula for interval x0, x1. In the starting class we can say the general quadrature formula. In the general quadrature formula we can put n is equal to 1. Then we are getting integral of a to b y dx is equal to h into n y0 plus n square by 2 delta y0, because n is equal to 1 we can substitute. For the interval x0 is equal to x1. So x values goes to x0 to x1 y dx is equal to h into, you can put on n is equal to 1, that is y0 plus n square, that is 1 square, that is 1 by 2 into delta y0. Okay, now h into y0 plus, already for delta is called as a forward difference operator. Forward difference operator form applied, we can get the value delta y0 as y1 minus y0 by 2. Now you can take the LCM, 2 y0 plus y1 minus y0 by 2. 2 y0 minus y0, that is y0 plus y1 by 2. So finally you are getting h by 2 into y0 plus yn. In the interval x0 to x1 we are getting the value h by 2 into y0 plus y1. Similarly we can apply integral of x1 to x2 y dx. We are getting the value h by 2 into y1 plus y2. Because we are getting x0 to x1, then we are getting y0 plus y1. So similar manner x1 to x2, then obviously you are getting y1 plus y2 and so on. You are getting and so on. You are getting all above integrals we can add. Integral of x0 to x1 a to b y dx is equal to h by 2 into y0 plus y1 plus y1 plus y2 and so on y. Adding above all integrals we are getting y0 plus y1, that is y0, y1 plus y1 2y1, y2 plus y2 2y2, y3 plus y3 2y3 and so on y. Here individual terms is goes to y0 plus yn. We can write h by 2 into y0 plus yn. In the middle terms 2y1, 2y2, 2y3 and so on. In these all terms we can take the common 2 as, then we are getting y1 plus y2 plus and so on yn minus 1, where h value becomes to b minus a by n. So this one is trapezoidal theorem proof. Okay, right. Next we can go by model 2, that means Simpson's 1/3 rule. Okay, Simpson's 1/3 rule formula is goes to, let y is equal to f of x be a function, then formula is goes to integral of a to b y dx is equal to h by 3 into y0 plus yn plus 2 into even terms, that is y2 plus y4 plus y6 plus and so on yn minus 2 plus 4 into odd terms, that is y1 plus y3 and so on yn minus 1. And also h is the common form, h is equal to b minus a by n. This is the Simpson's 1/3 rule. Again, once I repeat the formula, given function is, we can treat it as y is equal to f of x be a function. Formula is goes to integral of a to b y dx is equal to h by 3 into y naught plus yn. That means first term and last term, plus 2 into even terms, that is y2 plus y4 plus y6 and so on yn minus 2, plus 4 into y1 plus y3 and so on yn minus 1, where h is equal to b minus a by n. Simply you can remember it as h by 3, Simpson's 1/3, that means you can remember h by 3, y naught plus yn, that means starting value and ending value, plus 2 into even terms plus 4 into odd terms. Shortly you can remember h by 3 into y naught plus yn plus 2 into even terms plus 4 into odd terms, that is 2, 4, 6, 1, 3, 5 and so on. Okay, next we can done one problem in this model. Right. So one is evaluate integral of 0 to 1 by 1 plus x square dx by using Simpson's 1/3 rule, and also obtain the approximate value of pi. Okay, right. Given integration, we can write it as given integral of a to b y dx is equal to integral of 0 to 1 by 1 plus x square dx. Okay, here a is equal to 0, b is equal to 1 and n is equal to 6, h is equal to b minus a by n. In Simpson's 1/3 rule, he is not given n ordinates, then obviously you can look as n is equal to 6. So h value we can find out 1 minus 0 by 6, that is 1 by 6. That value becomes to 0.1667 approximately. So we can make the x values. Starting x value becomes to 0. That is x naught is equal to a. You can write a plus h, 0 plus h value 0.1667. Then you are getting 0.1667. Now again you can add 0.1667 plus 0.1667. Then we are getting third ordinate. Again in each term you are adding 0.1667. Then you are getting x naught, x1, x2, x3, x4, x5 and the last value is 1. Now we are getting y values. Suppose if x is equal to 0, okay, x is equal to 0, then you are getting y value is goes to 1 by 1, that is 1. Next, x is equal to 0.1667. X is equal to, you can put on x is equal to 0.1667 in this place. Then you are getting 1 by 1 plus 0.1667 whole square. In simplifying, you are getting the value 0.9729 by using scientific calculator. Then you are getting the answer. Again you can substitute x is equal to 0.3334. Again 1 by 1 plus 0.3334 whole square, and scientific calculator you are using, then you are getting the value 0.899999. Okay, in the similar manner you have to put on x is equal to 0.5001, 0.6668, 0.8335, and the last value is x is equal to 1. X is equal to 1 means 1 by 1 plus 1 square, that is 1. 1 by 1 plus 1, 1 by 2. 1 by 2 is goes to 0.5. Okay, so now you can read this one is y0, y1, y2, y3, y4, y5, y6. Okay, starting value y0 and ending value y6. Okay, by using Simpson's 1/3 rule, already we can learn integral of a to b y dx is equal to h by 3 into y0 plus yn plus 2 into even terms plus 4 into odd terms. Okay, so integral, once I repeat the formula, h by 3 into y0 plus yn plus 2 into even terms, 4 into odd terms. Here y values goes to y0, y1, y2, y3, y4, y5, y6. That means starting value y0, ending value y6. Right, you can write the formula y0 plus yn, repeat the formula y0 plus y6 plus 2 into even terms, y2 plus y4, 4 into odd terms, y1 plus y3 plus y5. H values goes to 0.1667 by 3, y0, that means starting value 1, ending value 1 by 2 0.5, 2 into even terms plus 4 into odd terms. So simplifying we are getting the answer 0.7854. First we can add in these two numbers 1 plus 0.5 1.5, 2 into some value, that value becomes to 3.3302 and 4 into some value 9.4516. Totally we are simplifying, we are getting the value 0.7854. That is integral 0 to 1 1 by 1 plus x squared dx. But he is asking exact value of pi. Okay, now exact value integral 0 to 1 1 by 1 plus x squared dx. We can done the above problem. We are getting the value 0.7854. But in general integration, in the intermediate level, we are learn about integration. Integral of 1 by 1 plus x square, that formula goes to tan inverse x 1 0, upper limit minus lower limit, tan inverse of 1 minus tan inverse of 0, tan inverse of 1 can be written as tan 45. So tan inverse of tan pi by 4 minus tan inverse of 0, tan 0 is 0, tan inverse of tan theta, theta, that means 0. Again you can apply the same formula, tan inverse of tan pi by 4, tan inverse of tan 45 pi by 4 minus 0 is pi by 4 is equal to 0.7854. Pi value becomes to 0.7854 into 4. That is pi value we are getting exact value 3.14. Already this is the exact value. He is asking find the exact value. So we can use Simpson's 1/3 rule. We can find this solution. Integral 0 to 1 1 by 1 plus x square dx value is goes to 0.7854, and also we can evaluate exact value of pi in this integration. We can find pi value 3.14. Okay, thank you.